Okay, so in this problem, what we're going to do is look at a situation that involves a system of equations, and we're going to use matrices to solve it just because that's kind of where we are right now. This situation is a little bit different as we're going to discover. So you're getting ready to buy prizes for a giveaway, and you have 50 people who are coming to this thing. So you want to make sure that everybody gets a prize. So we're going to make sure that we get 50 prizes. And our budget is going to be $500. I originally started with a different number, and I wanted to use this one. So the main idea is that there are three types of prizes that we want to give. There are prizes that cost $5, there's prizes that cost 10, and prizes that cost 20. So we want to know how many of each type of prize can we buy? And the answer might surprise you. So let's just take a look at what we have. So we have three different kinds of prizes, which tells us that we're going to have three unknowns. So I'm going to say that X is the number of type 1s, Y is the number of type 2s, and Z is the number of type 3s. And what do we know about this? Well, we know that we want to give away 50 prizes, so it tells us that the sum of the number of prizes that I get, which is X plus Y plus Z, has to be 50. And I know that my total cost has to be 500. Well, we know that each type 1 gift costs $5. That's 5X, and then that's 10Y, and that's 20Z. Now, before I put this into matrix form, I noticed that this equation can be reduced somewhat. I can divide both sides by 5 to get a simpler equation. So I'm going to do that. And there's where we are. So I am going to put this into matrix form. So 1, 1, 1, 50 on the top, and 1, 2, 4, 100 for the bottom. And then what I'm going to do right away is, and I encourage you to use your calculator to do this, but I'm going to find what's called the reduced row echelon form. And whether using a calculator or an online calculator, there's a ton out there. We're not going to go through this by hand, but here is where we end up because it's the solution that's really important here. We end up with 1, 0, negative 2, 0. We have 0, 1, 3, 50. So what on earth does that mean? Well, that means that the corresponding solution written in a simpler form is this. So let's just remember what this translates back to. So this means that we have x minus 2z equals 0, which in short means that x is equal to 2z. And we have y plus 3z equals 50, which means y is equal to 50 minus 3z. Notice I'm solving for x and y, because what it looks like is that x and y are both controlled by z, and z can be basically anything, right? So while that seems true on the surface, remember that we are attached to a word problem. So that means that z is actually confined to, since z is a number of prizes, this means that when I go shopping for prizes, I have to kind of look at the most expensive one first. Okay, so I'm just going to pick a couple values here. What this means is we technically have infinite solutions, but not really, because again, we're tied to an application. So only certain things make sense. We can't have decimals in our answer. We can't have negatives in our answer. And under certain circumstances, if you want to make sure you have a mixture of prizes, we have to make sure that none of them are 0. So I'm just going to try different things. I'm going to say, well, what if z is equal to 5? So I commit to getting 5 of the most expensive ones. I want 5 first prizes, let's say. Well, what does that mean that the rest of them are? So that means that, well, x is 2z, which is 2 times 5, which is 10. So let's just think about that for a second. If z is 5, x is 10. We already know what y has to be because we have a total of 50 gifts. And if I've already allocated for 15 gifts, I know that I should have 35. So let's just make sure that our formula works out. So you have 50 minus 3z, which is 50 minus 3 times 5, which is 50 minus 15, which is, oh, lo and behold, 35. Look at that. So there is one such solution. There are many others. If I decide to let z equals 10, this means x is equal to 2 times 10, which is 20. and I have y equals 50 minus 3 times 10, which is also 20. So there are many combinations of solutions depending on what your actual goals are. So if you wanted a specific solution, the thing to keep in mind is we would have to have another equation. Remember that if the number of equations and the number of variables match up, you stand a chance at getting a unique solution, unless one of the equations is the same as the other or something. But under normal circumstances, you're going to get one whole solution. So when there's fewer equations than there are variables, that's when infinite solutions can happen. So this is just one example of how we can do things like this in a business scenario. This is a very basic one as far as business goes, but hopefully you can see where how this can be extended to other situations. So thanks so much for watching.